In this video, we'll be continuing our Unit 1 test. We're looking at numbers 6 through 10. If you haven't completed the problems, you should do so before viewing this video. Which type of plot? Again, we would not be appropriate for assessing differences between the two groups. Reading the question, relatively minor repetitive impacts to heads can cause injuries. One indicator is called a radial something, diffusivity. The measurements of 12 right-handed male soccer players were compared to those of 11 swimmers. So the measurements of each, so each person is getting some measurement of some quantity. So for the 12 soccer players, we're going to have 12 numbers. For the 11 swimmers, we're going to have 11 numbers, and we want to compare them. A, stacked dot plots, one for each group on the same axis. This sounds reasonable if indeed dot plots are effective when we have repeated values that are the same. Okay, so I think this is a reasonable way to do it, so I'm going to cross off A. Side-by-side box plots, I think in general, comparing two groups, a box plot is a good way to do it. Okay. Stacked bar graphs. Well, bar graphs show percentages, and we're not dealing with percentages here. We're dealing with values for each one of these, so I'm inclined to say C here. D, back-to-back stem and leaf plot. That would be a reasonable way to do this. And E, a pair of histograms, one above another. A histogram and a stem and leaf plot are very similar displays, so D and E are definitely not right. What you're looking at here is A, B, D, and E are similar in that we're comparing specific numbers to each other. C is different. Bar graphs typically display percents. Okay, or counts, and we're not talking about displaying percents or counts in this problem. So C is displaying something different. C is different than the rest of those. Just good test taking techniques. C is different than the rest of those guys. Thus, we'll select it. Number 7. Get to the question sentence first. Which statement is true? Alright, the question says American automobiles produced in 2012 were classified as large. We have a mean of 19.6 and a standard deviation of 3.36. A particular model on this list is rated as 23 miles per gallon, given it a z-score. It's telling us the z-score for this model is 1.01. And we know a z-score is a number of standard deviations. Okay. Which statement is true based on this information? One thing I don't see in this problem is it doesn't say normal model. Doesn't say something to the effect of normally distributed. Okay. Normal is not mentioned in there. Z-score just means a number of standard deviations. Z-score does not refer to the normal model. While we use it frequently when we're dealing with the normal model, it is simply a number of standard deviations. So in this problem, normal model was not mentioned. Okay. A says, because the standard deviation is small compared to the mean, a normal model is appropriate. No, it doesn't say anything about normal model. B, again, it says normal model in B. Normal model was never mentioned in this problem. C, because 23 miles per gallon is greater than the mean, the distribution is skewed right. Well, we have in fact, not only does it not say normal, it doesn't give us anything about the shape, okay? No clue about shape. We don't know the mean. We don't know the median, so we cannot compare it to the mean. We can make no judgments about the shape of this distribution, okay? D, because no information was given about shape. It is not appropriate to use the z-score. Yeah, no information was given about shape. That's true. D is our best answer. Because no information was given about shape of distribution, it is not appropriate to calculate a z-score. No, that's not true. A z-score is simply a number of standard deviations. We can calculate the z-score without knowing anything about shape. So z-score has nothing to do with shape. It is simply a number of standard deviations. All right. Number 8. Get to the question sentence first. Based on the normal model, so this time we are assuming normality, we'd expect the middle 90% would be between what? All right, it says in 2011, approximately normal, mean of 64, standard deviation 11.7. Normal with a mean of 64 and a standard deviation of 11.7. Well, at this point, it should be like breathing. As soon as we see that it says normally distributed, we're going to draw our normal curve. Mean is 64. It's a bad normal curve that I drew. I'm sorry. Up 11.7 would be 75.7, and then up another 11.7 would be 87.4. All right, down 11.7 would be 52.3, and down another 11.7 would be 40.6. All right, we know, I also like breathing now, 68, 95, 99.7. Okay, so in here is 68%. Between these two, between this one and this one, we have 95%. 95%. So we're looking for the middle 90%. That's going to be slightly inside. It's going to be perhaps right here. Okay? Between these two marks, perhaps, is the middle 90%. We're looking for what this number would be here. Okay, and this number would be here that would mark this bound that is 90%. Well, hopefully you remember from our previous class, we know again this distribution is normally distributed with a mean of 64 and a standard deviation of 11.7. If I want to find this marker, this part, I can do inverse norm. Inverse norm. I write my percentile that I want. If I want this to be the middle 90%, all right, then what I want here is to be the 5th percent. And what I want here would be the 95%. From 5% to 95% would be the middle 90%. Okay. Inverse norm of 0.05, comma, mean of 64, and a standard deviation of 11.7. And that returns 44.75 40.76. And that looks reasonable. If that's 40.6, that saying this is 44, that looks real reasonable. Well, how much is it going to be on this other side? Well, it's about 4 up from there. So this side's going to be about 4 down. It's going to be in the 83 range. To find this side, I would go, to find this side, I'd go inverse norm of 0.95. It's the 95th percentile. 64 and 11.7. Okay. And it is indeed 83. This is approximately approximately 83. So from 44.7 to about 83, that looks like it is closest to C. Number 9, I'm looking for which statement about these results is correct. They give us a survey asking Wisconsin high school students, who do you text most during class? Family members, friends inside school, girlfriend, boyfriend, friends outside school. We were looking for a correct statement. A says the proportion of 9th graders who said they text family members is 19 over 57. So I'm concerned with the 9th grade column. Of my 9th graders, 19 out of 42 were texting family members. 19 over 57 is of the people that texted their family members, how many of those were 9th graders. So it's a different thing. Okay, we talked about our conditional probability. What we're looking at here is the proportion of 9th graders who said they text family members. So this A, what they're trying to say is the probability that you text family members, given you are a 9th grader. Okay, so remember, this is my denominator. The 9th grade here, it's 42. Okay, of that group, 19. It's 19 out of 42. This 19 out of 57 is given you texted family members, what proportion was 9th grade? So A, no good. B, among those who said they text girlfriend, boyfriend, so we're talking about given you text your boyfriend or girlfriend, I'm going to say GB, girlfriend or boyfriend, among those who said they text girlfriend, boyfriend, the proportion who are seniors is 21 out of 45. So I'm in my group here. That's 21 out of 52 seniors. Okay. My denominator is girlfriend, boyfriend. That's 52. Of that 52 group, the seniors is 21. Okay, so B, again, they have the conditional incorrect. C, the proportion of 10th graders. So our given is the 10th. The denominator is the 10th. So the 10th grade group, the denominator is 35. Okay. The proportion of 10th graders who said they text friends inside school. Friends inside school, that's 5. 5 out of 35 there. Greater than the proportion of all students who said that. So, friends inside school. Friends in school for the 10th graders. For all of those. So in this case, we're talking about in that group that texted friends inside school, that is 34 out of 160. So we want to compare this to 34 over 160. Well, 34 over 160, this is roughly a fifth, and that's a seventh. So this number is less than that one. So that is C is incorrect. 34 over 160 is greater than 5 over 35. D, a student who texts friends inside school is more likely to be a senior than is someone who texts friends outside of school. A student who texts friends inside of school. Okay, so if you're texting friends inside of school, you're this group right here. Okay. Are you more likely to be a senior than someone who texts friends outside of school? So we're comparing these two numbers. We're looking at the senior part of that. All right. So friends inside of school, 10 out of 34. Friends outside of school, 6 out of 17. We want to compare 10 out of 34 to 6 out of 17. 10 divided by 34 is 0.294. 6 divided by 17 is a little more than a third. It's 0.35. So this number is greater. And 6 over 17, this is the friends outside of school. Friends outside of school. So, no. Student who texts friends inside of school is more likely to be a senior than someone who texts friends outside of school. If you are texting folks, in this case, it's greater to be friends outside of school, so that is, D is incorrect. E, of all grade levels, 11th graders are least likely to text a girlfriend or a boyfriend. Okay. So now we're looking at the texting the girlfriend or the boyfriend column. 9th graders are the least likely. All right, E, of all the grade levels, 11th graders are least likely to text a girlfriend or boyfriend. So here the conditional is of all the grade levels. So it's necessary for us to look at four probabilities here. We want to look at the probability, and each time it's your grade level, and we're talking about texting girlfriend or boyfriend. Girlfriend or boyfriend, given you are a 9th grader. Girlfriend or boyfriend, given you are a 10th grader. Girlfriend or boyfriend, given you are 11th grader. And girlfriend or boyfriend, given you are a 12th grader. But this statement, of all the grade levels, the given is the particular grade level. So looking at my 9th grade only, looking at my 9th grade, we're talking about these 42 people. How many text boyfriend or girlfriend? 10. 10 out of 42. Okay, and that is approximately 0.238. Okay. Of the 10th grade, 12 out of 35, and that's just over a third. That's 0.34 approximately. The 11th grade, 9 out of 38. Not very many of those. Alright, 0.237. Slightly less than those in the 12th graders. 21 out of 45. And that is 0.47 roughly. So we see it indeed. The 11th grade, of all the grade levels, looking at the conditional probability of grade level, what percent are texting girlfriend or boyfriend? Indeed, it is E. I know what you're thinking. Couldn't I have just looked in here and said, hey, only 9 of the girlfriend or boyfriend? Well, we're concerned with a percentage here. And it's not the percent. It's not given I've texted my girlfriend or boyfriend. It is of all grade levels. We're looking at comparing a grade level conditional. All right. E is correct. Number 10. Which of the following cannot, again with a cannot, read the question sentence, it's so important, which cannot be concluded? Facebook has a larger proportion of users 45 plus. than Twitter. Yeah, that's true. We see Facebook, the 45 plus people, that's the largest section. It's larger than that 33. So we're looking for cannot. This one's out. I'm going to put a little T over here, meaning this statement is true, thus it's out. Sometimes I think that helps when you're trying to find a false thing. Okay. The smallest age group for both Facebook and Twitter users is 0 to 24. Zero to 24 is 14% in the Facebook. That's the smallest. It's 19% in Twitter. That's the smallest. That's a true statement. Thus, this one's out. Okay. C, there are about the same number of Facebook users as Twitter users. We're dealing with percentages here. It tells us nothing about the total counts. We do not know if this is true or false. It's not necessarily false. It's unknown, but I'm going to call it false. It looks like this is going to be my best answer. D, both Twitter and Facebook have more people in the 45 plus age group than any other. More people 45 plus in this one, yep. More people in 40, yep, that's true. So this one's out. E, a smaller proportion of Facebook users than Twitter users are in the 25 to 34. 25 to 34, that's this color. Smaller in Facebook than in Twitter. Yep, that's true, so that one's out. Yes, it is. 10 is C. Alright, that concludes this video.